Nitrogen has 5 valence electrons. It can form ammonia, NH3, by bonding with hydrogen and sharing hydrogen's electrons. That way, hydrogen gets its 2 valence electrons that it wants, and nitrogen ends up with 8 around it. We can draw this using sticks to represent bonds, lines to represent bonds. So this is ammonia, NH3. So this is a lone pair of electrons, and this is a bonding pair of electrons. Now, this lone pair of electrons on ammonia can actually donate both electrons to a bond when something comes along that doesn't have any electrons of its own. For example, a hydrogen ion. H plus has lost 1 electron, therefore is a positively charged ion. So what can happen is this H plus is attracted to that lone pair of electrons on nitrogen, and it can form what we call a coordinate covalent bond. Coordinate covalent bond is when one atom donates both electrons to the bond instead of one from each. 1 electron from each atom. So a regular covalent, you've got 1 electron from each atom. So this is a regular covalent bond. Because 1 atom donates 1 electron. Together, they share a pair. What happens during this coordinate covalent bond, along comes our H with no electron, and this pair of electron, this lone pair of electron on nitrogen donates both electrons to the bond. It came with a +1 charge, and it still has a +1 charge altogether. So this is the ammonium ion. Now the only thing is we don't know which one of these bonds is the coordinate covalent bond. There's no difference in appearance between any of the covalent or the coordinate covalent. So this is your Lewis structure for your ammonium ion. This happens in another case. This happens with the hydrogen ion, and we'll get into this a bit in acids and bases. Here, oxygen has 2 lone pairs of electrons, and again, we've got an H without its electron. It comes along, and oxygen can form a coordinate covalent bond, and what we end up with is the hydronium ion, which is very important in acids and bases. Again, we don't know which one of those bonds is the coordinate covalent one.